Hello and welcome to the section 10.3 lecture today for multiplying polynomials. This is kind of multiplying polynomials part 2. We did talk about multiplying polynomials yesterday, and yesterday we kind of focused on a monomial times some other type of polynomial. So having like one term times a lot of terms, and a lot of times that was distributive property. I guess every time that was distributive property. Today we're going to talk about some other forms of multiplying polynomials, like when I have two things times two other things. I want to use distributive property. And actually I want to back up a little bit and think about this as A times the parentheses and then B times the parentheses. And with a plus sign in between because B is positive. So I would have A times C plus D plus B times C plus D, and then distribute again. Okay, and this is kind of the long version if you've done this before. I guess I don't need parentheses at this point. Sweet. A times C, A times D, A times D plus B times C plus B times D. And so those are all the things that we get, and if we get any like terms, we want to combine them. Most of the time, I would say that we'll come up with at least one set of like terms. So let's try that in these two problems. Let's take x and multiply it by the parentheses, and then -2 and multiply it by the parentheses. X times x plus 3, and then -2 times x plus 3. Okay. Then we distribute again. X times x is x squared. X times 3 is 3x. -2 times x is -2x. And -2 times 3 is -6. I have like terms in the middle. And I'll combine those. Positive 3 and -2 gives me plus 1x and -6. In the next one, I'm doing the same thing. Take the x, multiply it by the parentheses, take the 1, multiply it by the parentheses. X times x squared plus, minus. Got to copy things down right, otherwise you get problems wrong. And then plus 1 times x squared minus 3x. X times x squared is actually x to the third power. X times -3x is negative 3x squared. 1 times x squared is x squared, and 1 times -3x is -3x. So these are all the terms that I get. Now I want to try to combine the like terms. Those are still right in the middle. -3 and positive 1 are going to give me -2x squared. And so that's what I get there. Now this is such a common thing that we have an acronym to help us out. And that acronym is called FOIL, where we want to find the product of the first terms, the outside terms, the inside terms, and the last terms. We end up doing it so often that this is just a little bit easier and a little bit better way to show it. So let's go ahead and give these a shot. So first times first, 4x times 3x, 4 times 3 is 12. X times x is x squared. 4x times 15. 4 times 15 is 60, and there's an x there. Now I'm going underneath. -6 times 3x is -18x. And -6 times 15 is 60, 30, 90. -90. I still have like terms right in the middle. I'll go ahead and combine those. I have 12x squared, 60 minus 18, how about 42? 42x and minus 90. And that's my answer. It's a little bit cleaner to use this FOIL process than it is to double distribute like we did in the first couple. Now here's an interesting problem. And it brings me to a really good point. This does not equal 2x squared plus 6 squared. It almost does, and that's what gets so many people in trouble. What does squaring mean? Squaring means taking something and multiplying it by itself. So I want to take the 2x plus 6 and multiply that by itself. Okay, now I'm just going to do my FOIL. I'm going to take my my first, outsides, insides, and lasts. 2x times 2x is 4x squared, which happens to be 2x squared. And I'm also going to get that 6 squared at the end, but it's the inside part that messes people up. And now I have 2x times 6, sorry, brain fart for a second. That's going to be 12x. 6 times 2x from the insides is another 12x, and 6 times 6 is 36. My like terms in the middle need to be combined. 4x squared plus 24x plus 36. If you do it incorrectly, most people would get this one and they would get this one, but they wouldn't get the one in the middle. Okay, I'm not saying that those can be combined like I usually do, but that's the mistake that a lot of people make. Let's look at this one. So I've got, I want to FOIL these as well. And something interesting is going to happen on this one because of the similarities and slight difference between these two polynomials. 5x times 5x, 5 times 5 is 25, and x times x is x squared. 5 times 3 is 15, and that has an x. Negative 3 times 5x is negative 15x, and negative 3 times positive 3 is negative 9. My like terms in the middle actually cancel each other out. I have a positive 15x and a negative 15x. So this one's definitely a special one in that it gives us only 2 terms as opposed to the 3 terms that the other ones had. But that's about the end of the interestingness that I really have. The last one I want to FOIL, and this one's going to come up with a little bit different result because of I have an x squared here. 3x squared times 2x, 3 times 2 is 6. X squared times x, that brings 3 x's into the equation. 3x squared times negative 3 is going to be negative 9 x squared. 5x times 2x would be 10 x squared. And 5x times negative 3 will be negative 15x. Okay. I want to combine my like terms in the middle. 6x cubed plus x squared minus 15x. Okay, let's go ahead and look at the next page, see what that looks like. When I have more terms multiplied on each one, that's just bringing more things that I want to think about distributing. Pretty much I want to multiply everything in the first set of parentheses by everything in the second. Or if I have a third set of parentheses, we'll do that as well. So I'm going to think about kind of a mix between the first problems I did and the FOILing. Okay, I'm going to multiply x squared by everything over here. Okay, so x squared times x to the 4th. Now this is something that we haven't really talked about yet, but I'm hoping you have elsewhere. That would turn into 6 x's all multiplied together. So that would give me x to the 6th. X squared times 2x is going to give me 2, and that'll be x to the 3rd. X squared times negative 5 will be negative 5 x squared. The next thing I'm going to do is multiply the 3x by everything, and I'm going to switch colors to show a little bit of differences here and how this is going to work. 3x times x to the 4th, that's going to be plus 3. And now there's 1x here, 4x's here, so that's 5 total x's. 3x times 2x, 3 times 2 is 6. That'll be an x squared. And 3x times negative 5 will be negative 15x. I'm going to run into this other problem, but I'll move it around in just a second and make it work out a little bit better. Actually, no, I'm just going to kind of tab down and do the last one down below. But I'm taking 1 and multiplying it by all 3 of these. That's not too bad. That just turns into 1 times x to the 4th is x to the 4th. 1 times 2x is 2x. And 1 times negative 5 is negative 5. So that's what this turns into. Now I have the difficult job of combining all my like terms, or at least the like terms that I have. There are no other x to the 6th, so that's by itself. There are no other, and so I'm actually going to cross it out here so that I know that I've dealt with it. There are no other x to the 5ths. That one's by itself. There are no other x to the 4ths, so that one's by itself. There's not going to be many things to combine here, but we will get a couple. There are no other x to the 3rd, so that one's by itself. There are 2 x squared terms, a negative 5 and a positive 6, so that's going to be 1 x squared. There are 2, let me cross those out, there are 2 x terms. Negative 15 and positive 2 is going to be negative 13. And there's 1 constant term of negative 5. What a long, ugly answer, but that is it. This next one's probably going to be a little bit nicer. Not much, but a little bit. Because I only have 2 things in the first one, so I'm going to multiply that 3x by everything. 3 times 2 is 6, and x times x squared is x to the 3rd. 3 times 3 is 9, x times x is x squared. And 3 times negative 1, or 3x times negative 1 is negative 3x. To make the combining part a little bit easier, I'm going to try to stack up my like terms now.
Mr. Lowe, please call Corky in the office. Mr. Lowe, please call Corky in the office. Thank you. 7175.
In an effort to make the combining a little bit easier, that's how we're going to do this. 2 times 2x squared is 4x squared. I'm putting that under my other x squared term. 2 times 3x is going to be 6x. That'll go under this one. And then 2 times negative 1 is just going to go on the end. Now the cool part about doing it this way is now I can just add these straight down, and it'll help me combining like terms. I could have done that over here. It just wouldn't have happened as easy because we had so many different terms. Again, I'm combining things that have the same variable and exponent combination. So this will have a 13x squared. Plus 3x and a minus 2. And then I always like that since I put that line there, I can use that to box in my answer. Kind of nice. For the next one, it's kind of like one that we've dealt with before in that it shows a polynomial raised to a power. Well, this is raised to the 3rd power, which just means, I'm actually going to try to cover up that 3rd power, x plus 1 times x plus 1. Okay, come on. Let's actually write things. Write things that we say. X plus 1 times x plus 1. I have 3 x plus 1s all multiplied together. And so really I want to treat this as a FOIL problem and then figure out what I have. Okay, so let's do that. X times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. So now I have this from the first 2, and then I have this other x plus 1 just hanging out over here. I can combine the middle 2 terms here to give me 2x, and bear with me, need those parentheses there. And now I want to treat it like the problem that we just did and multiply everything in the first set of parentheses by everything in the second. So x squared is going to be multiplied by the x and the 1. X squared times x is x to the third. X squared times 1 is x squared. I'm actually going to stack from here on. 2x times x is 2x squared. 2x times 1 is 2x. 1 times x is plus x, and 1 times 1 is plus 1. Now I kind of have 3 rows of things that I'm all adding together. Getting kind of ugly here. There's only one x cubed. X squared and 2x squared is 3x squared. 2x and 1x is 3x. And there's a plus 1 on the end. And that's what I get. So sometimes I can see where people would not really, something in our minds kind of likes things to be increasing in size. So sometimes I could see where people don't really like that this x plus 1, that the binomial's on the end. Well, I can change that using the associative property of multiplication. I can actually multiply these two together first. And I'm going to do that here because they look like the harder two, and then I'll just have to multiply in an x plus 1 at the end. So I'm going to leave that here and FOIL these two. For the first times first, 2x times x is 2x squared. Outsides, 2 times 4 is 8. That gives me 8x. Insides gives me 2 times x, which is 2x. And last gives me 2 times 4, which is 8. I do need to combine my like terms in that one that I just did. Otherwise, I'm going to distribute more things, and it's actually just a little overkill. 8 plus 2 is 10. And so we get this. Now I want to multiply everything in the first one by everything in the second one. X times 2x squared is going to be 2x cubed. X times 10x is going to be plus 10x squared. And x times 8 will be 8x. To multiply the 1 by everything, it's pretty straightforward. 1 times 2x squared is 2x squared. 1 times 10x is 10x. And 1 times 8 is 8. Now we can combine our like terms. 10 plus 2 is 12. 8 plus 10 is 18. And we have a plus 8. I went through those pretty quickly, but take your time as you're doing them. I've done a lot of them. So I'm pretty dang good at them. I know I made it look easy. It's really not that easy if you're struggling with this. Like I said, take your time. The benefit is that it is just multiplication, but you do have to know what happens with variables when you multiply them. So take it slow. Use what I've done to guide you in what you're doing. Otherwise, I hope you have a great day, and we'll see you in class.